Ladies and gentlemen, please welcome to the stage Guru Parulkar.
Good morning and welcome back. Welcome back to our third Open Networking Summit. I hope you are having a good ONS. So let me get you started with some highlights. So I thought I will share some highlights from yesterday and then would love to hear from you your highlights as well during the day. So the first, Windsurf. So of course, he shared a lot of wisdom and lessons learned from last 40 years and how we can learn and we can apply some of this to SDN. But he said something that went unnoticed, I thought, and that is, he said, Google is now using OpenFlow SDN inside the data centers. Now, last year, Urs gave a keynote talk and said that Google is using SDN to interconnect their data centers. And we suspected that Google is using OpenFlow and SDN inside data center. But yesterday was the first day or first time in a public setting, Google acknowledged that they're using OpenFlow and SDN inside the data center. And I was surprised that that went unnoticed, and this is the big news, and it has not yet become a news. Okay, so that was, I thought, interesting. Another thing that I thought highlight from my point of view is there were a number of if you go to the exhibit floor, you will see a number of very, very interesting exhibits that are demonstrating technologies as well as some use cases. And when you look at this technology, they are all across the SDN stack, all the way from, for example, Centec is doing OpenFlow optimized chip, and around that building a switch. Then Big Switch did Switch Lite, that is the switch library. You can take whatever a white box and turn that into a very good OpenFlow enabled box. So that is something, a big deal. Then of course different types of controllers, different types of switches for different segments, all the way from enterprise to top of the rack to service provider and optical transport switches. That was very good. And finally, we are also starting to see some very good applications and use cases. And they are all the way from security to virtualization to traffic engineering and in all different domains. And in today's keynote talks, we are going to see some of those apps and use cases as well. So that is a good trend. Research track, that was another highlight in my opinion, in the sense that we were doing an experiment to bring latest research into ONS so that the industry and academia can interact together. And number of people yesterday told me that that was so invaluable, that in networking that has not happened before. All the conferences are getting more and more separated. So ONS bringing the research and the industry together, that was very important. And then there are research in different aspects of SDN, all the way from scaling SDN to programming, debugging, applying SDN to layer 4 through 7. So very, very interesting research agenda that is taking shape. Okay, now there was a session about open source and open SDN. Again, I think open source SDN is great. I think that is the right thing to happen. Of course, it should be done right. Inder gave a very good talk on daylight, but he obviously painted a very rosy picture. He kind of didn't talk about some of the challenges and so on. And one thing he said that was very interesting to me. He said, Open Daylight is the first open source project where so many big companies are coming together to launch it. I thought, is it a strength or is it a weakness? Because every time an open source project has been successful, it starts with a small code base, small architects, developer community, it starts to have a users and then it builds on it. That is a typical recipe for an open source project. But anyway, I think I am still optimistic. Let's hope Open Daylight is successful in accomplishing what it means to. That will be very good for SDN. Okay. I should tell you two more things that I'm kind of a little bit disappointed, that we need to see more of SDN deployment stories. And that would be really good. We saw some of it, but not as much. On the other hand, yesterday was a little bit more vendor specific sessions. Today we are going to hear a lot more from Google, NTT Communications, Deutsche Telekom, eBay, Fidelity, Goldman Sachs. So all of these people are going to talk about how they are using SDN. So hopefully today we will feel better about that. And then I think developers, we still need to do more to bring developers to Open Networking Summit and have developers do something interesting at the summit. I think the developer tracks yesterday, I would say they were okay. They were more talking rather than developers doing something interesting. So I'm just doing some self-evaluation and saying we need to do more. Yesterday I talked about SDN washing, and today I want to tell you about one more thing that I'm concerned about, and then I will get to the keynote talks. I hope I don't take too much time. And so what I want to do is say that SDN approach that tries to preserve legacy is counterproductive. And it seems too good to be true sometimes, and let me tell you what I mean by that. So what I'm hearing is some of the vendors are promoting this idea that you can take your existing boxes, these are vertically integrated proprietary complex boxes, and we know that inside this there is heavyweight silicon, network router operating system and all of that, millions and millions of lines of code, lot of proprietary stuff that goes into it. Then they say, okay, we will layer on top of that SDN. We will give you like an OpenFlow interface, we will give you a vendor specific interface. Every vendor has some favorite interface that they want to put on top of this. Then you build a controller, and then they talk about building some applications. And then the claimed advantage is this allows customer to realize SDN on their existing infrastructure, and it allows vendor to build SDN on their existing boxes. At some level it seems pretty good, right? You can have your existing infrastructure, existing boxes, and do SDN. So the question is, what is wrong? I think what is wrong is that everything is wrong because it compromises the basic SDN. Okay? Let me explain what I mean by that. Okay? So if you imagine this particular thing, the most important thing is the forwarding state. The forwarding state in the box is what decides how you forward packets as they are coming in. Now in this model, what happens is there are many masters that are trying to control this forwarding state and manipulate this forwarding state. So the first one is all the distributed protocols that are embedded into the boxes that are trying to manipulate and manage the state. Then if you have OpenFlow there, OpenFlow is trying to manage this particular state. Then if you have a vendor specific protocol that is trying to manipulate this forwarding state and decide what to do with it. So under this case, how do you build a consistent network map that you can offer to the applications? And how do then you program these applications on top of that inconsistent network map? So there is a significant challenge. And so then if you ask the question, so the bottom line is these two control planes, I mean we know that the original control plane is broken, it does not give you what you want. Now you add another control plane on top of it, you have multiple masters that are trying to manage how to do packet forwarding. Can we get this right? Are we simplifying it, or are we making life much harder? So if you look at what is this, right? One of the value proposition of SDN is to enable innovations through programming. If you make this thing so complex, are you really making it easier to innovate? I doubt it. Then accelerate new revenue generating services for network operators and owners. If you make this model so complicated, right, can you really write these applications, or only vendors can write the applications that can you bring? And then the current model continues, that vendors are the only ones that can write interesting applications, and writing other applications become much, much harder for other people. Are you reducing capex and opex with this model? You take all these complex boxes where you are paying 60 and 70% margins. On top of that, you add another layer of software. Do you think it is going to cost less for the customers? You think opex is going to go down with this? So I think this is something we should carefully think through if we are really going to make SDN successful. With that, so I think, okay, so last thing is, we know you cannot have a cake and eat it too. So sometimes things look easier, but make sure that we are not getting trapped again and we lose a big opportunity with SDN, that is help the customers bring innovation, bring revenue generating services to the world. Okay. with that, let me introduce our first keynote speaker. I'm delighted to have Bethany from HP to be our first keynote speaker of the day. So let me tell you a little bit about her. I got to know her only last few months as we were talking about ONS and so on. So I don't know her that well. But here is the thing I know. She is responsible for all networking at HP. That is maybe over $2.5 billion in revenue. So that's a pretty big number to run a business like that. She has been around. She has worked in different types of companies as well as across the networking ecosystem. She has done engineering, marketing, operations, so she has a pretty broad overview. And by all the different metrics, she is considered one of the most influential high-tech executive in the country. So with that, here is Bethany.
Thank you, Guru. Wow, that was a really nice welcome, actually. I did not know I was one of the most influential women executives in the country. That's kind of scary. Anyways, thank you so much, Guru, for letting me speak here and also for allowing HP to participate in ONS. This is a really exciting event for us, and actually it's a really exciting time for HP and HP networking. We've been involved in this SDN environment for a long time with the ONF, and so it's great to see things coming to fruition. So in my presentation, I'm going to talk a little bit about what we think SDN is, and hopefully it'll match with what Guru thinks it is. And then also, we're going to talk about the applications that we've already deployed, and we're going to have a customer who's deployed one of the applications that we created with another customer in his environment. First, I just want to say I have been in the industry for a very long time. In fact, this is my 20th year in the networking industry, if you can believe it. I can't, but anyways, it is what it is. And so I've been here for a very long time, and I've seen the changes, or I would say lack of changes, in the networking industry over the last 20 years. What's interesting to me about the networking industry is that, frankly, it has remained almost the same in terms of how we do networking since when I started in the networking world in 1993. Essentially, that has been a very manually based, CLI-oriented networking environment where we spend lots and lots of time running around programming different devices, trying to ensure that the network will work for the business. And the problem has been that, unfortunately, after all of the automation in the server environment and the storage environment and the rest of the infrastructure, networking has lagged behind. And in fact, now it has become a stumbling block for some of the things that are really important to the business and to the industry. So I'm going to talk a little bit about some of those drivers for why SDN is so important. So the first one of those drivers is, frankly, that the cloud is now here in many, many senses, both private as well as public clouds. And I spend a lot of time with enterprise customers talking to them about their needs. And what I would tell you is they all want to create a cloud, whether it's a private cloud or whether it's a public cloud. And the problem that they have is, frankly, the network. Because the network cannot do things quickly. You cannot re-provision and reconfigure a network in minutes or hours or even days. It takes months. And everything else, you can bring up a virtual machine and you can start an application on that virtual machine on a server in a matter of minutes. You cannot do that with the network. And so their inability to be agile and move quickly to the cloud is a problem. Why? Because the IT organization is going to start being irrelevant if they cannot, if they can't meet the business requirements quickly. So agility is a problem for them. And folks will go to the cloud whether they are part of it or whether they're not. Also, there are continuing to be a proliferation of devices. I'm carrying 3 today. I had 4 at one point. I don't know where the other one went, but right now I'm at 3. And I will tell you that that's going to just continue. So we're going to all continue to have more and more devices over time. And that has an impact on the network. Because every time you bring a device into the network, it has to do something with it. It has to know about it. It has to track it, et cetera. So that's going to be an issue. And then what I will tell you is the momentum in the world of SDN and what SDN means to the networking market is going to, I think, increase fairly dramatically over the course of the next 3 to 5 to 7 years. We're going to see growth in this market because it's been 20 years, and it's so complex, and it's so fragile. And that's why SDN is going to be and is so important to every customer I speak to. This is a good example of what I'm talking about. So this is a cloud where you might want to say this cloud provider is deploying 50,000 users. That's not a lot of users, by the way, in a public cloud. And what's happening with that? Well, what you can tell is the network isn't really accommodating it. Today, the way we would reprovision a network or change it would take over 3,000 hours of effort and 420 network administrators. It takes a long time, as I said, and this is really not feasible. So SDN is really a networking paradigm shift. It aligns the network with the business objectives. So instead of making the network as stumbling blocks, it actually becomes part of the mechanism that allows a business to make changes it needs to drive business forward. So it provides flexibility in network usage. It provides very rapid application deployment, and we're actually demonstrating one of those applications, link, in fact, at the show. So I'd love you to come and take a look at that. And it also provides lower operating costs and less complexity because the amount of people, time, and money it takes to make changes to a network and to ensure that it is flexible is significantly lowered as a result. So as with ONF, we use the same definition of software-defined networking. And what that boils down to is, frankly, the separation of the control and the data planes, and the abstraction of the devices themselves, the device layer in the network, so that essentially you have a single point or a distributed point of logical control. And that's our version of software-defined networking. It happens to also be the same definition as ONF. We've been spending many years, by the way, in this environment. In fact, we started working in OpenFlow, which is the precursor to where we are now with SDN, in 2007. Our HP Labs, which, by the way, has been involved in this since 2007 and has continued to create technology for us to use within HP, has participated in this with Nick McEwen back in 2007 on ethane. So we've continued to progress here. We were also, just so that you know, the first commercially available switch that has OpenFlow enablement in it. We also have spent many years partnering with several customers across the industry on SDN and OpenFlow enablement in their networks using our products. And more recently, we have built our own SDN Controller, and I'll talk a little bit about that in a few minutes. But the goal that I want to share with you on this slide is we have been doing this for a long time. It may not have been called SDN when we started it, but it has been at the heart of what we do within HP networking. And we also spend a lot of time in the industry. We're a leader in ONF. We're actually one of the founding members of ONF. As I mentioned, we are the first and now the largest deployed OpenFlow-enabled switching environment in the world. We have 15 million OpenFlow-enabled ports. We have also been very involved in the working groups on ETSI, which is for network function virtualization, which I'm sure many of you are beginning to talk about and think about. And we have been in OpenStack as a leader in the OpenStack community and continue to do that across the entirety of our infrastructure products. So let's talk about what SDN looks like from an HP perspective. First, you have an infrastructure that is made up of devices, and those devices have an open programmable interface. In the case for HP, it is primarily OpenFlow. You have a controller that is a logically centralized control plane that manages those devices and abstracts that device environment from the administrator and the user. And then you have northbound APIs that are programmable as well for different kinds of applications, whether it's for cloud or whether it's for other kinds of network services applications that I'll talk about in a minute. What it isn't, to be clear, is it's not simply having a virtual machine that is host to host across two servers that have no understanding of what goes on beneath them on the devices themselves. That's an application called network virtualization. It is not SDN. It is an application of SDN. But the fact that you cannot understand tunneling across two hosts, you cannot understand the devices that are beneath it or know anything about them or know whether or not they've changed or know whether or not they've been re-provisioned is a problem. Because essentially, there's no commitment that network hasn't changed. And that when you do that tunneling, that tunnel will provide you the quality of service you're looking for. So that's not SDN. That is an application of SDN called network virtualization. It also isn't programming interfaces on boxes, as Guru mentioned. That's not SDN either. In fact, in my position, in my opinion, that's kind of the opposite of SDN, because essentially, if you can program each of these devices separately using an API, and you make them all different, how is that providing consistency? And it certainly doesn't provide a single point of control, because every single one of those devices will be controlling itself. And finally, it isn't the end of hardware innovation. HP and HP networking has been in the ASICs development environment for many, many years. And what that means to us is essentially we can provide enhanced performance in an environment using our ASICs in those boxes. So that's a very important innovation that will continue and actually add value in the SDN world. So let me just give you a sense of what our solution is. First, we have over 29 OpenFlow-enabled switches in our portfolio, and we will be going to complete all of our switches in OpenFlow enablement over the course of this year. And as I mentioned, we have 15 million ports of OpenFlow-enabled devices in the market today. Recently, actually last year, we began development, and we are now in beta with our SDN Controller with over 70 customers. And we also are in live networks with our SDN Controller as well. And one of our customers is here today, and he's going to talk about that briefly. So we've developed our own SDN Controller, which utilizes OpenFlow to access those devices and control them, as well as we've created APIs, open programmable APIs, for different kinds of applications that we've developed with customers. So one is network virtualization for the cloud. We've developed that along with our HP Cloud customer base, which is, of course, within HP, but nevertheless, that's who uses our network virtualization. We developed an application with HBO that is a security application. I'll talk a bit about this as well. Very interesting application to protect the edge of the network where the edge has sort of vanished. And we've also developed, along with CERN, a load balancing application. As you know, CERN moves petabytes of data around the nuclear information that they provide to many, many, many users in the world across their data center. And so we developed a load balancing application with them. And we're going to continue because we're going to extend it even further. We do believe there will be an evolution here, and there will be other interfaces to devices, and so we're willing to look at those and support them if necessary. We also utilize our Intelligent Management Center. This is our management platform that manages all of our devices, and actually thousands of other people's devices as well. But that management center provides network management services in addition to the SDN controller. And we've worked with companies like F5, where we've integrated their IAPs into the Intelligent Management Center, and that provides tremendous capability in the layer 4 through 7 area, so ensuring that the network is prepared for different applications going across it, as well as the ability to instantly deploy applications where we'd like to see them. So let's talk about some of the applications that we've created. First, there's the virtual cloud network application, which is a virtualization of the network, as I mentioned. And we've done this with our HP Cloud, which then offers a multi-tenant environment for a number of different users. The HP Cloud is a publicly available cloud. We offer infrastructure to our customer base, and they required a multi-tenancy capability on the network. And so we developed that with them using our SDN controller. And what you can see is that we've integrated with OpenStack and the Quantum driver in particular to be able to essentially integrate our SDN controller in a cloud environment and have the multi-tenancy that our customer is looking for. And what it brings is very scalable cloud automation, because essentially it allows that organization, HP Cloud, to then change the network as necessary and add users as necessary as they gain new customers. And it provides public-private cloud integration, where they can essentially utilize either a private cloud for a customer and their public cloud in combination to ensure that the customer has what they need to deliver the compute requirements they're looking for. Another application that we developed along with Intel and Verizon, and actually I'm not going to spend a whole lot of time on this because Rose and Verizon are going to spend some time on this in just a few minutes, but it's a really interesting application where it's dynamic WAN bandwidth provisioning. So the idea here is that the service provider can offer a cloud bursting capability to their customer. So their customer may have a private cloud in their own data center, or may need extra computing resources outside of their data center, and they can burst to the service provider's data center, and there will be a dynamic change in the WAN bandwidth provided to them, so that when that bursting occurs, they will get the performance they're looking for, as, for example, if they're moving virtual machines around. So it's a really nice application, and I'll let Rose tell you more about it. But what it brings is automated provisioning, so you can have that network provisioned immediately based on the requirements of that bursting, on-demand scalability, so bringing the network up or down and depending upon the needs, and a disaster avoidance so that the customer can move quickly to another data center if necessary, if they're having a problem in their own private cloud. This is a really neat application that was announced yesterday. There was some press on it, and I'd like to say it's one of the most interesting applications I've seen. And I think, frankly, there's going to be a lot more of these. We will see more and more applications we haven't thought of going forward. But the idea here is this utilizes a link API that is integrated with our SDN controller, and the network itself will dynamically provision for link calls or video or desktop sharing. So right now what happens is the network is over-provisioned when you have link on it, because you just don't know, if someone's going to do a video, or if someone's going to make a phone call, or if it's desktop sharing time, and the bandwidth requirements there are very heavy. And so what if the network could just dynamically provision itself as a call is brought up, and then re-provision it to other sources needed when the call's torn down? That's the idea around this. It's a really unique application, and one that I think you'll find very interesting, and one that we're demoing here at the show. So it brings simplified policy deployment, because essentially using policy that's already put in place, the network dynamically senses what's going on, that there's a link activity occurring, there's a link call or video, and it changes as a result of that. And prioritization is dynamic. When link is on, it gets reprioritized, and when it's not, that prioritization changes. And finally, of course, user-enhanced experience. You get a better user experience with link when you have an application like this deployed in your network. And then finally, our Sentinel security application. And this is also another very interesting application that I don't know that folks really thought about using SDN for. But think about all of the security devices we use in the network today, and frankly, all of the appliances we use. The problem with security appliances are essentially they're a choke point, first of all, and that you're dragging bad traffic across that network to get to the choke point. With Sentinel, what we've done is we've dissolved the security, and in particular IPS, into the switching fabric itself. Okay, so how do we do that? Well, remember we have a product called Tipping Point. Tipping Point is a world-class IPS. One of the things that Tipping Point offers is a cloud-based signature capability that allows the tipping point appliance to then be downloaded with the latest signatures to block malware or bad sites. Well, we're using the cloud, and we're integrating that with the SDN controller. So the SDN controller then pushes those signatures all the way out to the switching ports themselves, whether it's a wireless access point or whether it's a wired switch. So that when the user comes in with their device, and by the way, this happens quite frequently with BYOD, and that device has something bad on it, or they go to a bad website, instead of that traffic having to go all the way to the IPS and the DMZ, it is blocked at the port in which the device is connected, whether that's an access point or a wired switch. That's unique. And frankly, it also brings a promise that we've been trying to create in this environment for a very long time, which is dissolving capabilities like security into the switching fabric itself and allowing that switching fabric to stop bad traffic, to stop bad behavior at the port at which it occurs. So it's a wonderful application. And in fact, we have a customer here that I want to introduce you to, Greg Bell, who's with Ballarat. And Ballarat's a public school district in Australia, and he's actually deployed this in his network. So I'm going to have Greg come up and talk with you about this. Greg.
Thank you, Bethany.
You're welcome.
Good morning, everyone. My name is Greg Bell. I'm from Ballarat Grammar School in Australia, and I'd like to begin by telling you a little about our school. Grammar is a large regional school in Australia. We have 3 campuses. We have our city campus in Melbourne, we have our farm for agriculture studies, and we have our main campus in Ballarat. We have around 1,400 students, and we have 200 staff, and 250 of our students are boarders who live on campus, and the school is their home during the school year. We have a number of challenges with meeting their IT requirements. We have a mix of managed and BYOD devices. We have school provisioned devices for the students in our senior school, so that's around 900 machines, and we have a one-to-one program for our teaching staff. For our boarders, we have a BYOD program where the students in the boarding house are allowed to bring their devices in from home, whether that's another laptop they'd like to use or a desktop, just to make them feel more comfortable during their stay in the boarding house. We have a lot of challenges meeting their requirements and giving them a great network experience and keeping a decent level of network security. Lack of visibility and control. We have no real visibility with spyware and malware on these devices. With the school provision devices, obviously we push out antivirus and antivirus definitions and things like that, so we can be reasonably confident that those machines are clean, but with the students' personal devices, we really have no idea what's happening on those machines. We have a lot of great security measures in place on the network. We have a sonic wall firewall with intrusion prevention. We have a web content filter which prevents the students from getting to a lot of the nasty phishing websites and things like that. But we have noticed a steady increase in the number of malware and spyware infections on the student machines. While we were beta testing some other software for HP networking, we were discussing some of our challenges around meeting network security with our mix of users and devices. And as part of that conversation, we were given the opportunity to test HP's new Sentinel product. So even though it was early in the development cycle for Sentinel, we were given the chance to try it out and see if it could meet some of the challenges that we were facing. Just prior to our Sentinel deployment, we had upgraded all of the networking infrastructure in the boarding houses. So we have 5 boarding houses, and we had upgraded their infrastructure with HP 3800 switches, with a lot of brand new access points and 10 gig optical fibre back to the core. We were able to take advantage of the the free upgrade to the OpenFlow software on the 3800s. So when we rolled Sentinel out to the boarding houses, there was no time delay and no real downtime for those parts of the school. When we initially deployed Sentinel, we didn't have a great appreciation of its value. We deployed it during the school holidays when the boarders were, they'd gone back home for a couple of weeks. But as soon as they returned, that is when we noticed Sentinel immediately started blocking thousands of DNS requests coming from those student devices. It was a mix of their personal devices that they brought in from home and their school provision devices. And to give you a specific example, there was one device in particular. Sentinel was blocking hundreds of DNS requests from this device over a very short period of time, and this device got our attention. We were able to use Sentinel to see which infections were coming from this machine. We were able to look at the IP address and trace this device back to its owner. And that gave us the power to be more proactive with being able to contact that student and say, look, you need to come in, we need to tidy up your machine and get you back out there. And that is the kind of proactive approach that we haven't had before with network security. We have not had that power before. And Sentinel has, in a way, revolutionised the approach that we can take towards the spyware and malware, and we can react instantly if we need to. Another great feature we've enjoyed with Sentinel is the DNS blacklisting. We have a challenge at the moment with keeping our students and some staff focused during class time. It's almost epidemic. Our students are obsessed with Facebook. So we were instructed by the senior members of the school to push out a rule to limit their Facebook access during class time. And with our content filter, that was a challenge because Facebook defaults to the SSL version of their website. So to have some reasonable control over blocking the Facebook site to a schedule was quite tricky. But we were able to use the DNS blacklist feature in Sentinel to create a schedule where Facebook is denied during class hours but open before and after class. And we think that helps encourage the students to be more engaged with their teachers and fellow classmates. So we can already see that with giving us better visibility and control of the spyware and malware that's out there on the devices and things like the DNS blacklist, it's exposed a need to sort of supplement an area where we know we're exposed. And while it's hard to measure the return on investment that we've had from Sentinel, there's no doubt that it really does fill those gaps, and it is a valuable addition to our network. And it goes to show that Sentinel and software-defined networking really are the perfect match for the campus LAN. Just like the Link UC&C demo, it just goes to show that it's really there and it can help the end users. It's not just for the data centre or the cloud.
Thank you, Greg.
Thank you, Bethany.
Yeah, I think he gets a clap for all those kids that come in with iPads and iPhones. And I know when my granddaughter uses my iPad, I get very frightened. So thank you, Greg. So it just gives you a sense of what SDN can be used for that's not just the data center, which a lot of people think about and focus on. SDN will be used across the entirety of the network. And it's going to be very, very valuable in all kinds of ways that, as I said, I don't think we've even thought of yet. So I just briefly wanted to mention how to start your journey and how to proceed forward. We don't think this is going to be an overnight switch. We think this is going to take time and that people are going to look at SDN and utilize it in a very controlled manner. starting with basically perhaps having a small lab or a sandbox with SDN and playing with some of the applications in their, that they're thinking about using for their network, and then perhaps proceeding on a segment-by-segment basis, deploying SDN in their network for different purposes. So we do think this is going to take time and that this is an evolution. And we're very comfortable with that because, frankly, we've been doing this evolution for a while ourselves already. But we have really gone all in on this from an HPN perspective, and for very good reason, actually. It fits very, very well with our value proposition to our customers. And as I said, the network's been very complex and very fragile, and the HPN value proposition is all about simplification and simplicity of the network, whether it's the deployment of the network, whether it's the architecture of the network, whether it's the management and maintenance of the network. Simplifying the network is really what's going to allow the network to be a vital part of changes that are needed for the business to do its job and to grow and be successful. And so that's really key to us, and that's why SDN is so important to us. So I'll just close by saying we have been doing this for a long time, and we really feel that this is the way we think HP networking will continue to be of great value to our customers and grow, as well as that we can offer tremendous new applications around SDN. So our innovative solutions and some of the things that you'll see if you take a look in the exhibit hall that we're demoing, as well as talking to Greg, that's what we've been doing, and that's what we're going to continue to do. And we believe we will see more and more applications. We'll create applications with our customers, and our customers will create applications as well. So I think that's all I have for you today in terms of my talk. I don't know if I have any time. Oh, I do have time. OK, good. Anyways, thank you very much.
So thank you again. Yeah, we do have time for a few questions, so feel free to go to the mic and ask questions.
Aaron Gumber, University of Wisconsin. We've actually had HP switches in our research test bed since 2009. And the more we work with them, the more we find that there's an unfortunate trade-off between the performance they can offer and how well they conform to the OpenFlow standard. We seem to lose a lot of flexibility in terms of simple things like priority. So I was wondering if you could speak a little bit about how HP is working to make sure we can get suitable performance, while also get the promises that the OpenFlow standard gives to us in terms of flexibility.
Sure. Thank you. And thanks for working with us for the last several years. I appreciate that. So our goal is to continue to increase performance. And by the way, as I said, we have an ASIC development team that we continue to work on ASICs that will continue to enhance performance for OpenFlow. And so we do not want to have a trade-off between OpenFlow performance and the utilization of OpenFlow in the network. So the idea here is to continue to increase performance using our ASICs over the course of the next several years. And so we've invested very heavily there. We've invested even more so over the last year because we understand what that'll mean for SDN and what you're looking for over the course of the next few years as you deploy SDN more and more in different applications or network virtualization. So our goal is to ensure that we provide you that performance, and the way we're planning to do it is primarily in ASICs, but also in a combination of our work on our SDN controller and those ASICs within our products. So thank you very much. And I have other smart guys in the room who can answer questions.
Let's go to, OK, go ahead.
Thank you. Bethany, the SDN purist view seems to imply all the value gets extracted in software, the hardware gets dumbed down. Yet you seem to still be implying that there's plenty to be had in terms of the hardware side with your own ASIC strategy. Was wondering, are the days of 60-point margins over? Do you still think there's enough on the hardware side to warrant differentiation? I'd love to hear more on that point.
Well, since we don't advertise our margins, I can't tell you what they are. But anyways, so I think value, people pay for value. Whether it's in software or whether it's in hardware, they pay because they get value for something. And so our belief, and our very strong belief, and many of the vendors who are focused on development in ASICs, is that ASICs are valuable, and hardware in its own way has value. And so if we put value there, people will be willing to pay for it. If we don't, fair enough. They don't have to. But with ASIC development and the ability to create a better performing network using it, people actually want that. And you can't do a lot of functions, like, for example, deep packet inspections, a good example of this. That actually causes very slow performance in the network if done only in software, oftentimes. I don't want to offend anybody. But it often needs a little boost from the chipset or an ASIC. And so that's why I think there continues to be value in the devices themselves. And I agree, though, that the control mechanism needs to be centralized. That's my opinion, and I know that's Guru's, but the ASIC will help.
You want to put more value in ASIC, but the only thing is you should be able to get to that value through some programmability. If you are not able to get to that value easily, then it becomes a barrier and only the vendors can get to that, then it is probably a barrier. Right. So that is something to, anyway, but I think I want to.
Just to your point, Guru, so that's what we do, right? We use OpenFlow and we've enabled it in our ASIC.
Yeah.
So we don't, if it's somebody else's controller, yeah, that's fine. I don't care.
Yeah.
If it's our controller, I hope you like it. But the bottom line is, you're right. It has to be something that is open to the ASIC itself, and the ASIC can perform some value. So that's my opinion.
Okay, but let's get more questions in.
Thank you. My name is David Yazdani. I'm with Cisco. I just want to be honest and ask you some open question. I think Dan Pitt is right behind me. He's going to probably ask more questions about openness and what OpenFlow can do and SDN can do. I was thinking, and I was looking at your chart, 60 customers in 4 or 5 years, maybe? 5 years period. I think that's a very slow growth, in my opinion. That's personal.
Okay. 60 customers doing what?
SDN customers?
No. Those are beta customers since last October, my friend.
Okay. So that's great.
FYI.
That's great. Very good. Excellent.
I'll be a little more direct.
So there are 60 beta customers. And my questions are, I've been a partner with HP. We did Merrill Lynch together at Unified Communications. Yeah. And the link presentation you have here in the show, we did it 7 years ago, provisioning UC over the VPN. It's pretty much the same concept. What I want to know is what the difference is really with SDN, one thing, and what is slowing down the SDN from going forward? What can we do to make it speedy and go forward better?
Thank you. That's a very good question. So the difference from an SDN perspective is the dynamic flow, the understanding of dynamic flows in the network. SDN can actually do that, and that's not often done unless you actually go switch by switch by switch and provision them to have some level of content awareness. And then also you have to over-provision them very often. You have to ensure that there's additional bandwidth there because, frankly, when you have lots of different applications running on the network, and we all know video is very, very heavy application and takes a lot of bandwidth. If you do not provision at a very high level when you have manual provisioning, you get in trouble, and the user experience is lessened. This is where SDN and the network itself senses flows going across it and then changes thresholds as a result of that. I mean, I think frankly, that's very different than what we've been doing in the past. And I think that's why it's such a promising capability. And then in terms of where I think it's going to go, gosh, I think this concept, the SDN concept and the paradigm itself, it's going to have a very dramatic effect. And I'm not sure. People say, well, hardware is dead, this and that. Time will tell. Time will tell. Vendors like HP and I'm sure Cisco and Intel, we want to provide value to our customers. That's our goal. And I'm very happy to provide it in both software and hardware. I'm very comfortable with that. I'm comfortable with whether the switch port sits on a server, sits in a storage device, sits on a switch. I'm comfortable with that too. So the goal there is to provide value for our customers, and that's what we're attempting to do here.
Okay, let's take the last question because it is Dan. I cannot say no to him, so okay, it is Dan.
Hi,
Go
Dan.
ahead.
Hi, Bethany. Dan Pitt, Open Networking Foundation.
Yes.
I'm an alumnus of HP from the mid-'90s, back when networking was sort of on the neglected periphery of HP's business. I had a conversation with a senior executive at the time. I was complaining why we didn't do more with networking, and he said, and I quote, "Listen, Dan, if we were really serious about networking, we would just buy Cisco."
Oh.
At the time, that was affordable in market cap. So my question is, how do you see HP's networking business working with your server, application middleware, and professional services arms to bring comprehensive SDN solutions to the market?
Right. Thank you. Okay, that's a good question. Yeah. And you know what? We went and bought Cisco's competitor 3Com instead, so that worked out really well for us. And in fact, we've been growing, just to be clear, we've grown now 13 consecutive quarters year over year. So it actually was a very good investment for HP. And you know, we're continuing to be very positive on networking and growing that business. So with regard to our servers and storage, HP has a strategy, and it's a real strategy, and there's lots of R&D behind it called converged infrastructure, where the idea, again, back to that simplification concept, where we're integrating technologies together intelligently to provide value for the customer so that the customer doesn't spend the majority of their time, which they do today, on maintaining all these different silos of technology, where they can essentially have a much easier experience in operating their infrastructure and focus more of their time on innovation, you know, in whatever their business requires. So our focus in the HP enterprise group, which is the larger instantiation of server storage, networking, and also services, has been around converged infrastructure, and it's been, our customer base has been very, very excited about the possibilities and also the technology we've begun to roll out there. So we're going to continue in that path, and as I said, you know, from my perspective, the switching port can be in a server, it can be in storage, it can be in a device. I'm comfortable with that because, frankly, whatever it allows the customer to then have a better experience and then provide them more value, as I was mentioning, also lowering their operating costs, that's what we're trying to do. That's the goal of our converged infrastructure strategy, the R&D behind it, and you know, all of our work there. So anyway,
okay.
Thank you.
Thank you.
Okay.
Again.